This is Miss Humbert here. Today we're going to be doing Unit 4 Notes 4. So we're going to be talking about special case factoring. So let's go ahead and let's take a look at what we need to do for special case factoring. The first type of special case factoring is differences of squares. So if you're subtracting two perfect squares, so that means that your b term is going to be 0. So differences of two squares takes the form ax squared minus c. And then when you factor, you have one parenthesis that has a plus and one parenthesis that has a minus. So let's take a look at the steps of factoring differences of squares. So when you're factoring differences of squares, first of all, see if there's a GCF. You're only going to take out the greatest common factor if it is to make perfect squares. Because in order to use differences of squares, you need to have two perfect squares. Then you're going to set it up into factored form. So a plus in one and a minus in the other. You're going to take the square root of each term. You put the square root of the first term in the first spot of each parenthesis and the square root of the second term in each spot in each parenthesis. So now that seems like a lot of words, so let's go ahead and let's take a look at what that's going to look like. So for number 1, first of all, I see that I have two terms. They are both perfect squares. N squared, any even exponent is a perfect square. And think of your numbers that are perfect squares. 4, 9, 16, 25. 36, 49, so forth. All of those are perfect squares. So because I have two perfect squares and no greatest common factor that I can take out, I can make my two parentheses. So I'm going to make my two parentheses. I'm going to put a plus in one parenthesis and a minus in the other. The first thing I'm going to do is take the square root of the first term. Well, the square root of any letter squared is just that letter. So the square root of n squared is just n. So I'm going to put that in the first spot of each term. Then I'm going to take the square root of 25. Well, the square root of 25 is going to be 5. So I'm going to put 5 in each of my terms. And this right here is your factored form. So it saves you the work of having to do the x because you can use this little trick. Well, let's take a look at number 2. So for number 2, I see that I have two perfect squares. So I'm going to set up my two parentheses. I'm going to put a plus in one and a minus in the other. So I'm going to take the square root of the first one and the square root of the second one. So the square root of the first is the first term. First of all, the square root of 36 is just 6. So I'm going to put 6 in the first spot of each parenthesis. The square root of x squared is x, so I'm going to put an x in each parenthesis. Then I'm going to go ahead and I'm going to take the square root of 49. Well, the square root of 49 is 7, and the square root of y squared is y, so I'm going to write that along with it. Alright, so that is your final answer for number 2. Next, let's take a look at number 3. So for number 3, right now I don't have perfect squares. Odd exponents are not perfect squares. Likewise, 48 and 12 are not perfect squares. Well, conveniently, I can take out a greatest common factor. So between 12 and 48, I can actually divide out a 12. And I can also take out an a out of each term. So I'm dividing each of these by 12a. Okay, so 48 divided by 12, well, that's going to give you 4. A cubed divided by a to the first is just a, and then squared. Negative 12a over negative 12a is negative 1. So that right there is not your final answer because you can use differences of squares to factor that guy right there. So you have 12a. And now we're going to use differences of squares. So I'm going to set up my two parentheses. So I have a plus in one and a minus in the other. So the first thing I'm going to do is take the square root of the first term. The square root of 4 is 2. So I have 2 here and 2 here. The square root of a squared is a. So I'm going to put a there and there. Then I'm going to do the square root of a second term. So a lot of people don't know this, but 1 is actually a perfect square. The square root of 1 is 1. So I'm going to put a 1 in the second spot of each term. So this right here is my final answer for number 3. Let's take a look at number 4. So for number 4, we're going to create two parentheses. So out of the first group, I can factor out, out of all of these, I can take out an x. I need to focus. Okay, so I need to take out that GCF of x in order to have perfect squares. So I'm going to make two groups. So then I'm going to do a plus and a minus. So then, once you take out x, you're left with 9x squared minus 4. So once you divide out that x, you do have perfect squares. So the square root of 9x squared, that's going to go in the first pot. The square root of 9 is 3, so I'm going to put a 3 here and a 3 here. Square root of x squared is just x. I'm going to put x here, x here. Then the square root of 4 is 2, so I'm going to put 2 here and 2 here. So notice that I still have my greatest common factor on there because that needs to be a part of my final answer, my greatest common factor. All right, so let's take a look at number 5. So I noticed for number 5, 64 is a perfect square, g squared is a perfect square, and h squared is a perfect square. So I can go ahead and I can set up my parentheses. So what I'm going to do is I'm going to take the square root of the first term and the square root of the second term. Well, the square root of 64 is 8. Remember, I put a plus in one and a minus in the other. The square root of 8 is 8. So I'm going to put an 8 in the first spot of each parenthesis. Then the square root of h squared is, or g squared is g. Square root of anything squared is just that letter. So I have g's in each of those spots that apparently look like y's. Then I need to take the square root of h squared. Well, the square root of h squared is just going to be h. So this right here is my differences of squares. Don't believe me? Go ahead and use the box method. I bet you get the same answer as you did for the original problem. Okay, so this one's written out a little bit differently. So I'm going to do two things. First of all, I notice I can take a y out, and I want to take a y out because I need to have a greatest common factor. Or I need to have perfect squares, and I can get perfect squares by taking out a greatest common factor. Now, I need to have a plus and a minus sign. In order for differences of squares to work, I need to have one negative sign and one positive sign, which I have here. They're just in a different order than we're used to seeing. So I'm going to go ahead and I'm going to divide out my GCF, and then I'm just going to rewrite it so that that minus sign's in the middle, because that's just how I'm used to seeing it. So I'm going to have a positive 9 here minus 4y squared here. Okay, so now that's how I'm used to seeing it. I'm used to seeing it with the minus in the middle, so I just rewrote it that way. So now I'm going to go ahead and I'm going to factor this using differences of squares. So I have this y out front, and then I'm going to go ahead and I'm going to make my two terms. So then I'm going to put a plus in one and a minus in the other. So then I have the square root of the first term, that goes here. And then I have the square root of the second term, that goes here. So square root of 4 is 2, and then we have y and y. So this right here is your final answer for number 6. So that's all that's going to be on your note video today. You are going to watch part 2 tomorrow in class once you've had a chance to practice differences of squares. So please make sure that you bring headphones to class tomorrow and take the Schoology quiz once you're done. Thanks for listening.